Hydrogen bonding. It's one of those important topics that's deceptively named because hydrogen bonding is not really about bonding. Hydrogen bonding is about an attractive force. So the kind of bonds that we have in chemistry are covalent bonds, ionic bonds, and metallic bonds. There's three kinds of really true bonds. Those are strong bonds that hold atoms and molecules or together, right? It holds atoms, ions together in kind of a permanent relationship inside of a molecule or inside of a crystal. Hydrogen bonds are things that attract molecules to each other in more of a transient relationship. They're fairly strong for attractive forces between molecules. They're pretty important. Without them, we wouldn't exist. We wouldn't be alive. Life wouldn't exist on Earth. But they're not bonds, so deceptively named. So an intermolecular force. What does it mean to be intermolecular, right? Inter means between. So we're talking about two different molecules experiencing an intermolecular force means between the two different molecules. We're not talking about inside of a molecule. We're talking about here's a molecule, what attracts this molecule to that one, right? Okay, so we need to find out what the characteristics of that hydrogen bond, which is not a bond, that force, what the characteristics are. So we need certain things to be present in the molecules in order for a hydrogen bond to happen. In the first molecule, right, in this molecule, we either need a nitrogen with a lone pair, or an oxygen with a lone pair, or a fluorine with a lone pair. Any one of these can be present, but one of these must be present, okay? In the second molecule, we have to have a nitrogen attached to a hydrogen. There's where the hydrogen comes from. Or an oxygen with a hydrogen, or a fluorine with a hydrogen. And it has to be one of those in the second molecule. And then we're going to talk about what causes these two molecules to be attracted to each other. So let's draw an instance of this. We have a nitrogen in a molecule. Let's make this an ammonia molecule, NH3. So here's my little trigonal pyramid, cute little guy, right, with his lone pair. So he's going to be hydrogen bonded to, he can be hydrogen bonded to another ammonia molecule, or he could be bonded to a different kind of molecule. Let's just make him bonded to a water molecule in this instance. So here's a water molecule, a little bent molecule, right? And there we go. There's my hydrogen bond. I've got, in one molecule, I've got the nitrogen lone pair. In the other molecule, I've got the oxygen hydrogen. And the hydrogen bond is the attraction between this molecule and this one. Okay? Now let's make another hydrogen bond. I could make another one coming out of this nitrogen hydrogen. He could be this part of the hydrogen bond, and then the water could be the part with the lone pair, right? He's got a couple of lone pairs going on here. There we are. So now the hydrogen bond is between this oxygen lone pair and the hydrogen nitrogen. Notice it's always in a straight line. Oxygen straight through the lone pair, straight through the hydrogen, straight through to the nitrogen. We have this highly electronegative atom. This highly electronegative atom, very small and electronegative is what's necessary here, with a hydrogen in between and this lone pair in between. Okay? All right. So we could have another water here. You don't have to be hydrogen bonded to somebody that's different than you. It can be the same kind of molecule, right? So we have a little hydrogen bond going on in between here, right? The oxygen lone pair, hydrogen bonded to a hydrogen oxygen. These two molecules, this molecule is hydrogen bonded to that molecule. Can't draw the hydrogens being bonded to each other because that would be partially positive attracted to partially positive. So this is kind of a special case of a dipole-dipole force, of a polar molecule being attracted to a polar molecule. It's just extra, extra strong. If water were just a polar molecule being attracted to a polar molecule, it would boil at minus 80 degrees Celsius. And all water on Earth basically would be gas. It wouldn't be liquid or solid. And since we're mainly made of water, we wouldn't exist to be talking about hydrogen bonding and how it's misnamed. So hydrogen bonding, super important.